Hi, Algebra 2. Let's go ahead and take a look at the notes for section 4.4. So you've got your notes handy, you've got something to write with. Go ahead and put a label down for your notes, 4.4, solving quadratics by graphing and factoring. So the first thing we want to talk about is zeros of a function, right? So write this down. The zero of a function is the value of the input x that makes the output f of x equal to 0. Another way to think about that is, what value can I put in for x that makes the y equal to 0? And when we look at that visually, those are your x-intercepts, right? So what are the zeros of the function that you see pictured here? So you can see where this graph crosses the x-axis at x equals 2 and x equals -5. So those are my zeros, 2 and -5. Now in this one, it was relatively easy to see. Doesn't always work out that way, though. And as you remember from Algebra 1, it's not always super easy or convenient to graph a quadratic by hand. We did some practice of this in the first part of Chapter 4, and it's a little tedious. It requires you to be pretty sharp with your math skills in terms of simplifying expressions. And if the zeros aren't exactly on a grid line, really doing it by paper is not much of a help. Technology obviously helps quite a bit. If you take a look at the image that you can see on the screen, if we just took the 5 points from the axis of symmetry and then those 4 other points that we use, we would end up with these 5 points down here. I would have no clue where this crosses the x-axis. I eventually had to use 9 inputs before I got to where my y values were 0. So technology makes that job quite a bit easier. So I'd like you to go ahead and try one together. Find the zeros of this function. F of x equals x squared plus 2x minus 3, using a graph and a table. So you may remember that first we need to find is the axis of symmetry. My a value is the multiplier on x squared. B is the multiplier on just plain x, and c is my constant. So if b is 2, I have -2 over 2 times a, which is 1. So -2 over 2, which equals -1. So my axis of symmetry happens where x equals 1. Okay, that's tremendous. So then what? Well, I need 2 more values for x here and 2 more here. So if I'm thinking about -1, what are my next 2 x values to the right? Well, I'm going to come across 0 and 1. What about going left? -2 and -3. So I need to know what this value is. So I want the f of -1. So I have -1 squared plus 2 times -1 minus 3. So -1 squared is 1. 2 times -1 is -2, and then minus 3. That's going to be -4. All right, so remember, because of symmetry, these two values, whatever their y is, it's going to be the exact same y here. So I don't need to plug in all 4 of these. I only need to pick either these 2 or these 2, and I get to choose. So I'm going to take the one that I think is going to be easiest to work with. And let's be honest, I'd rather use 0 and 1 than have to substitute in these negative values. So let's do f of, 0 first. What happens when I substitute 0 in here? 0 squared is 0. 2 times 0 is 0. So when my x is 0, these first 2 terms are going to drop out. The whole expression is equal to whatever c is, which is -3. So we get a little bit of a freebie here. When x is 0, I don't even have to do the math on this. All I have to do is take a look and see what my constant is. So now we just need to substitute in 1. So f of 1, 1 squared plus 2 times 1 minus 3. So that's 1 plus 2 minus 3. That's 0. All right. So now I know what my zeros are. If I go ahead and graph this, I have -1, -4. I have 0, -3, 1, 0. Over here, -2, -3, and -3, 0. So there's my symmetry, right? So this graph would look something like that. So again, kind of tedious to do that by hand. You probably really wouldn't want to do that by hand if you didn't have to. But we were able to find the zeros, which is x equals 1 and x equals -3. So here's one you can try on your own. Go ahead and pause the video and try the work. All right, so if you're able to come up with a value there, there's a couple different ways you can do this. If you go and do your -b over 2a, you get -1 over 2 times 1, -1/2, which is not a really nice number to want to put in for your axis of symmetry. Try to find the values of the coordinates of the vertex. So if we had -1/2, and then say we did 0 and 1, and then -1, -2, if we went ahead and substituted these in, we still wouldn't have our zeros by using a graph and a table. It would take a lot of work, and we really wouldn't get what we want out of this. So let's think about this maybe a different way. So if you did work this out and got x equals -2 and x equals -3, like where could that possibly come from? Let's think about something called the zero product property. What the zero product property tells us is if I have two things or more than two things and I multiply together and I get 0 for their product, then at least one of the quantities has to be equal to 0. The way we write that algebraically is if AB equals 0, then A is 0 or B is 0. So if we got asked to find, let's say, the zeros on this expression, well, if we make this thing equal to 0 and factor it, we can find the roots of the equation, the values of the variable that make that equation true. When is this thing equal to 0? So if we did go ahead and factor it, maybe it's been a minute since you factored anything. So let's remind ourselves of how that works. I need two numbers that multiply to make 12, and those same two numbers multiply to make -8. Right? Like, where does that come from? Well, think about what happens when you multiply two binomials. These first values here, I multiplied together and got x squared. That's x times x. These last two numbers, I multiplied together and got 12. Okay, well, 1 times 12, 2 times 6, 3 times 4. There's three different pairs of numbers that make 12. Which ones do I use? Well, I also know that they add up to make 8. So that's 2 and 6. It's -8, so I know both of those values are negative. So x minus 2, x equals 6. So let's go one more step further. What if I asked you to solve this expression? So instead of 0 equals this, I'm going to write it in its factored form. X minus 2 times x minus 6 is exactly the same thing as this. All I did was write it in a different way. What do I get out of that? Well, look, these two things multiplied together make 0, right? So now I know x minus 2 equals 0 or x minus 6 equals 0 by the zero product property. So I'm super interested in knowing what value of x makes this true. Well, let's solve it. X equals 2. Or let's solve this one. X equals 6. So this is your process for using the zero product property to be able to solve quadratics by factoring. And we're going to get a chance to get some practice on this in a Desmos activity.